Independent events. Let me explain the independent events in this video. Two events A and B are independent if the fact that A occurs does not affect the probability of B occurring. Let me explain this. Assume there is a box in front of us and there are 7 balls in it. Case 1 with replacement. Assuming that there are 7 balls in the box with 3 of them being yellow and 4 of them being red, let's calculate the probability of finding a yellow ball on the first attempt. Since there are a total of 7 balls and 3 of them are yellow, the probability of selecting a yellow ball on the first attempt is 3/7. Now, let's move on the second attempt. What we did, we picked one ball from the box and put it back. We will again pick a ball from the box, write down its color and put it back. Since the number of yellow and red balls remains the same, the probability of selecting a yellow ball on the second attempt is also 3/7. This holds true for any subsequent attempts as well. The probability of selecting a yellow ball remains the same because the number of yellow and red balls in the box remain constant throughout the process. As a result, the probability of selecting a yellow ball on any attempt is always 3/7. We understand this second attempt does not depend on the first attempt. Third attempt does not depend on the second or first attempt. Therefore, this type of experiments are called independent. Case 2 without replacement. Let's consider a different approach. We will pick a single ball from the box on the first attempt and write down the color, but this time we will leave it outside of the box. What is the probability having a yellow ball at first attempt? There are 3 yellow balls out of 7. Therefore, probability of having a yellow ball at first attempt is 3/7. We have first here and leave it outside of the box. Moving on to the second attempt, the probability of having a yellow ball depends on whether the ball we pick on the first attempt was yellow or red. If the ball we pick on the first attempt was yellow and left outside of the box, there would now be 2 yellow balls and 4 red balls left in the box. Therefore, the probability of having a yellow ball on the second attempt would be 2/6, as there are now only 6 balls left in the box. On the other hand, the probability change if the ball picked on the first attempt is red and left outside of the box. If we continue this, you can understand second attempt depend on the first attempt and third attempt depend on the second and first attempt, and also probabilities are not the same. This type of experiments are not independent. They are called dependent experiment. Now let me explain multiplication rule for independent events. If A and B are independent, probability of A and B can be written as probability of A times probability of B. Probability of A and B equal probability of A times probability of B if and only if A and B are independent. What is the meaning of if and only if? It means we can consider both ways. First one, if A and B are independent, this is satisfied. If this is satisfied, that means probability of A and B equal probability of A times probability of B, then we can say A and B are independent. How do we change the addition rule for the independent events? What is the addition rule? Probability of A union B equal probability of A plus probability of B minus probability of A intersection B. We know that if A and B are independent, we can write the intersection as multiplication of two probabilities of the events. Yes, therefore we can write this one, probability of A intersection B equal probability of A times probability of B. So modification of the multiplication rule is probability of A union B equal probability of A plus probability of B minus probability of A times probability of B. I will explain some examples in my next videos.